welcome everyone to today's Synergist webinar, Cloud Computing and the Internet of Things in IH Field Analysis. I'm Kay Bechtold, Senior Editor of the Synergist, the magazine of the American Industrial Hygiene Association. I'd like to thank all of our attendees, and especially SGS Galson, for sponsoring today's webinar. We originally had two speakers scheduled for today's webinar, but one is unable to join us due to a conflict. So Tim Quinn will be the primary speaker leading today's presentation. Tim is a Business Development Manager for SGS Galson and a subject matter expert on cloud computing. As a reminder, as we go through today's presentation, if you'd like to ask a question, please type it into the chat window on the right side of the screen and send to all panelists. We will have a Q&A at the end of Tim's presentation, but we may have an opportunity during the presentation for questions as well. And now I'll turn the presentation over to Tim.
Well, thanks, Kay. I appreciate everybody having me. It's an interesting new dynamic in the industrial hygiene field. I'm sure all of us have heard the terms cloud computing in the last few years. The Internet of Things is something a little newer, but that is something also that is being talked about. And really what we wanted to put together in this presentation was, how does that mean anything in the industrial hygiene field? What is cloud computing and what is the Internet of Things? And what does it mean to me? What we're going to go through probably in the next 30 minutes, and I've given this talk once before at a conference in Hawaii, and I found that what this did was folks have some sort of questions or ideas of what this is in their own minds, but by the time we get through the material, they have come up with other questions and other things that they're very curious about. So that's all we're trying to do here. We're going to start from a 50,000-foot level, and we're going to drill it down through time. By the end of the talk, hopefully this will give you a clear idea of what is here today, what's coming soon, and what's coming into the future when it comes to technology integration in the industrial hygiene field analysis. So let's go ahead and set the stage. Again, you know, who saw personal computers evolving they are today back in the 1980s, early 90s when they started? Obviously, we can do more things on our smartphone than we could do with our first 1, 2, 3 PCs. In fact, I went to college in the late 80s, early 90s, and I barely could type our term papers on a computer word processor. You can do more things now with your smartphone than ever before. The key to this is the microprocessing technology, Intel, AMD, all these other Silicon Valley-based companies, Qualcomm. They're making processors obviously smaller, lighter, more powerful, and this allows to innovate more things around that. As each new generation of technology is released, you'll see a new generation of technology around that being released. Cellular technology. We're close to entering 5G. We're in 4G now, which allows to do easily stream video. I see folks all the time now watching live TV on their smartphones sitting at a restaurant. 5G is now a whole other quantum leap further in technology that will allow things like artificial intelligence, all kinds of futuristic type things will now be reality within a short period of time. With the cellular technology and connectivity is the Internet. Again, the Internet is changing, it's dynamic, but who saw the things that we have going on today back when, you know, when we first started to get really going in the early to late 90s? Computers, as well as fiber optic communication, all these things are run together when we're talking about the Internet, the communications path, and the computing power of PCs. So our objectives today are pretty clear. Again, like I said, I have to drill down from 50,000 feet. What we're going to talk about is real-time and industrial hygiene sampling. What is available today and what drove the changes? We'll go back in time briefly. And the next generation platforms, how do you understand it? What sorts of technology is available today? And what can you do with this new cloud computing type platforms? And what could be coming within the next 6 months to a year? So real-time IH sampling, and we need to define what real-time is. Real-time is getting results, as they say, as they occur. Traditionally in the industrial hygiene field, again, this is a generalization, but we go out and we pull some air in various forms or ways, badges, things of that sort. You send them through some sort of courier, And if you're lucky, at least with our company, you get your results within 5 business days. It's just the way it's been done forever. Again, like I just said, we'll be sampling, waiting for results from a lab, pulling air through a collection media, and again, a delay in data. What we're talking about now is the quantum leap from this technology into instantaneous remote monitoring in various forms. What are the advantages of this? Well, obviously, if we took a survey, most people would want instantaneous data than they would rather than waiting a week to 10 days. The key advantages, though, is once you have this data and know that there is an issue or a problem, it's quicker in reaction, it's quicker in remediation. It gives you instant evaluation factors to go through corrective measures. Again, for the consultants that are in the field, you guys know exactly what I'm talking about. Well, not just consultants, but even IHs or CIHs that work locally within an organization or a big corporation. Key elements in industrial hygiene. Again, we all know this. This goes back to your CIH testing days or even your IH testing days. Regulatory compliance. Anything you use, any pieces of equipment you rent or you own or you buy, obviously needs to be compliant with regulatory standards, meet detection limits, obviously needs to be accurate, obviously needs to be specific. The sensitivity and specificity is always something that comes up, and I'll be honest with you, and this will probably be a question later, is with this new technology, the number one question I get all the time is, how do I know this works? And I'll get into that. Screening applications may not be wired for compliance. Performance, again, we just talked about. How do I know does this device work? How easy is it? That's the other thing too. How easy are these new devices to use? Is it complicated to set up? What do I need to be able to make sure this is working properly? And we'll get into that. And also, a factor is cost effectiveness, and how much does this really cost to use? We'll get into that. And again, from a 50,000-foot view. Regulatory compliance, again, we should all be compliant, and we should go through the accuracy and the sensitivity and specificity. Sorry, I think that was a redundant slide. The key elements, again, when we're talking about regulatory compliance, all have seen these logos and know who these folks are. Again, when you're talking about industrial hygiene and remote sensor technology and cloud computing and the Internet of Things, it gets very complicated because those are all different technologies, but what's happening is they are colliding, and they are all being measured and evaluated by different organizations. This isn't something that's wild, wild west, and no one's monitoring these things. There are overlook organizations and things we have to go to as organizations when releasing these types of devices. Performance. Again, the devices have to meet user requirements. So what does that mean? In the new technology of Internet of Things, it has to be easy. It has to be, the data itself has to be easily digested. And more importantly, the data that comes out the back end is going to be large amounts of data. So we see data storage. It should say actually data mining. In our experience, if you have a remote monitor out there monitoring, taking data points every 30 seconds for a month, in my experience, if you go to run a report of that complete compilation of data, I've seen a number of lines between 30 and 40,000 lines of data points on just one sensor. Some devices now have the ability to do up to 6 sensors simultaneously, taking readings between 30 seconds and a minute. You have that device deployed for 1 month, you're talking about hundreds of thousands of data points. That is now being tackled through data mining sort of folks that have seen an opportunity in this business, and it is starting to come to fruition, but that was something that was lagging behind the hardware technology. Key elements used, again, how am I able to view this data? Do I have to be there and look at the LCD screen like you would do now on some sort of devices? Say like a noise detector, you would go there and pull the data off a SIM card, or I'm sorry, a small little media device. The whole key of cloud computing is being able to access data through the internet and through the cloud. And this is just a representation of how easy will it be for me to look, view, understand, and digest data. And again, ultimately, what's the key? It's the ability to mine that data, run reports, pull graphs, look at statistical numerical values, and have that mean something to you and to your client, most importantly. Cost effectiveness. Cost effectiveness is dependent purely on the components themselves. Just like personal computers, laptops, PCs, tablets, you'll see, again, cost over time to be being reduced basically on volume. When manufacturers, and volumes increase, when the worldwide demand increases, costs go down. It's simple supply and demand. Right now, we're on the cutting edge on the front side of this sort of new cloud computing and IH field analysis, but the costs are coming down quickly. And again, there's different methods and there's different companies out there. There are companies in the Bay Area who sell these devices, mostly targeted at residential, and what their key is they don't make their money on the hardware, they're looking for monthly subscriptions for the data analysis. There are other companies out there like ours who rent these devices to professionals, industrial hygiene consultants, or companies on a job-per-job basis. So there are many ways now that you can access this type of technology. It just depends what fits your particular scenario. Understanding, again, what's available today and what drove the changes. So again, sliding back into the 80s, even the early 90s, what are the drivers of this technology, and what has allowed us to get to where we are today? So from the 1980s now versus total particulate and area sampling, again, I think all of us are familiar with how to take a suck some air through a pump into a piece of media into a filter. But again, way back in the 80s, it was very labor intensive, right? You can read through this yourself, but again, from calibration of the pump to flow rates to making sure you have the right filter, make sure that you run the samples the right amount of time, complete your sampling event, fill out your chain of custody. Again, I think everybody here is very, very familiar with this. Drop it off at a FedEx location or a UPS location. In and out, back to the lab. Lab gets it. Sometimes there are errors that they can't read your writing on the chain of custody. And again, it's just all of these things. This is the way it's been done, and we're slowly moving away from this type of workflow into a new digital cloud-based Internet of Things type of a way of doing your job. So now what we do is, or what's available in the marketplace, is the instruments are pre-calibrated. Really, what you really need to worry about most is making sure that it's charged if you don't have a local area to plug in, especially if it's an outdoor application. What you do is you turn on most of these devices themselves. They self-initialize and go try to find their back-end system through the cloud automatically. Once this is connected and up and running, as long as you have a browser or internet connection on any connected device, phone, tablet, PC, you go to that browser site, log in and password, and you're up and running, and you're viewing instantaneous data on all sorts of various electrochemical sensors, particulate sensors, VOC sensors, whatever is commercially available from the sensor manufacturers is what can now be read in real time. The 1980s versus now in confined space, which is very, very interesting. There were some oxygen meters, all sorts of different older technology. And again, this was a labor-intensive exercise. Obviously, make sure that the instruments were calibrated, so they were charged, turn it on, read the readings, and then most importantly, have the attendant keep an eye on the occupants and making sure that it doesn't go down. The things that we can do now, it's automated, it's web-based, it's charging. When it comes to confined space, the one question I do get quite often is, well, if it's in confined space, let's say underground, how is the device itself able to connect to the web since it doesn't have some sort of line of sight or it's underground? And that's easily done through type of repeater technology or things of that sort, redundancy, repeating, and get you out to the outside. GPS, things of that sort will get you out there. But now there are different types of products that are available. Automatically it turns pumps on, you drop sampling hoses down, read instantly, HUS, CO, whatever you're looking for. It takes readings prior to entry, allows you to run entry time entries, and now you are remotely monitoring for sort of dangerous scenarios and remote attendance. There's also peripheral devices that also can be connected into these types of new technologies. So it's not just limited to what sorts of sensors are embedded inside these devices. Lots of companies, including ours, give you the ability through small gateway boxes, allow you to connect third-party peripheral devices into the technology that also gets it to the cloud. So that's an important point. It's not just limited to what you can fit into this box and the commercially available miniature sensors. There are ways to do peripheral devices around this technology. Particles in confined space. You'll see in the first row, industrial hygiene and then technology. And all we're trying to do here in this slide was just kind of show the mirroring of what has happened, what's progressed since the 80s until the 2010s and beyond. And you'll notice on the bottom row of their technology, you'll see clouds, sensor technology, and one other bullet that should be in there is the networking speed or the advancement into 4G, 5G. This whole continuum has, again, just slowly built upon itself to get us to where we are today. That's all this slide is representing. So this just didn't happen instantaneously. This is long in progress, and it has been building to this point. We are absolutely here today. This technology is available today, and it's doing nothing but getting more advanced, and the different types of sensor technology is getting broader. It was very limited about a year and a half ago, based purely on the sensor technology that was available. And again, it's getting broader and broader by the quarter. Next generation platforms, understanding how all the pieces fit and how you and the industrial hygiene field fit. So projecting forward, 2017 and beyond, again, the first row, industrial hygiene field and the technology field. You'll see that 2020, true mobile augmented reality. This may sound futuristic, but within the next year or so, we will be able to do predictive analytics in industrial hygiene. We'll be able to do all kinds of computing parameters that not only will it just sit out there and monitor for you, but we'll actually have the ability to say, hey, I've sensed this and this. We need to watch out for this. It's not quite here yet. Right now, what we have available in the field is devices and sensors that sense things. They'll tell you if everything is okay, which is good, but they'll also tell you when they detect something that's not okay and can alert you about that. That's the key. As opposed to getting an odor complaint and getting to that particular location and you're there at the right time, oh, I don't smell it anymore, that can be eliminated now. How about outdoor applications, say construction, and you put these out while they're doing, let's say, grading of dirt, and you'll have continuous perimeter monitoring. How many particles, what's the concentration of particles going outside the perimeter? Stuff that now was labor intensive is now automated.
Hi, Tim. It's Regina. Can you hear me?
I see that our audio is a little choppy. Why don't you chat me if I need to call back in?
Yes, please. Could you try to dial in for us? That would be great. So if you would just select communicate at the very top of your screen, you'll switch your audio, just disconnect to what you're using.
This slide here is, if you look at all of the tags, the GPS, sensors, gateways, clouds, these are all monikers that everybody's heard before. This is it's a interesting slide, but if you really digest this, you'll understand a little bit better what we're talking about when it comes to the cloud computing. Hold on a second.
Tim, can you hear me?
Let me try to call in. I'm sorry. It sounds like you guys are having a hard time, so hold on real quick.
Thanks, everyone, for your patience. Tim is just going to switch his audio. His voice over IP was a little choppy, so he's going to dial in. So just give us just a few moments, and he will get right back to us. Thank you.
Welcome to WebEx. Enter your access code or meeting number followed by pound.
Hi, everybody can hear me?
We can. Thank you.
Sorry about that. Hopefully this is better.
I believe that is better.
Let me continue. I'll continue with this Cloud Connect slide. I think you guys have all had plenty of time to digest this slide, but again, this is the continuum of everything that I've spoke about prior. Sensor technology. Number one question I get, how do we know this works? There are about 2 major sensor technology manufacturers in the world. Most every large corporation who makes devices, let's say Ray Systems, let's say Honeywell, let's say HKC, sorry. The technology themselves it's pretty ubiquitous because there's a streamlining of sensor technology. What everybody's done is they're using the same folks. They're just packaging up their own flavors of products around the same sensor technology. So I guess my point is the fear of some being better than others really isn't founded because it's all kind of the same technology. All the different folks that are providing products to the market are using kind of the same technology, and it has been vetted and has been fleshed for years. Modularity. What you're looking at here is actually a small miniaturized radio. So again, the ability for technology in the Bay Area technology manufacturers and innovators to miniaturize is allowing us all now to make and design different sorts of products. And again, this isn't just for industrial hygiene. This is for every vertical that's out there that you can think of. The miniaturization, just look at the technology in smartphones, how small smartphones have gotten over the last 15 years. It's because of the miniaturization of components. So this slide is very interesting. So when it comes to the Internet of Things, or IoT, one of the largest mitigating factors was the cost of attaching your piece of technology to the network. Now, AT&T, I think Verizon is also on the way to do it. Well, no, Verizon is on the way to do it. AT&T and probably the others are all going to fall into place. They're going to have data plans now that are very, very inexpensive that allow Internet of Things type devices to communicate their data through their networks at very, very low cost. As you can see here on one of those slides, it says unlimited access for $20 a year. So let me give you an example of that. Let's say General Electric, who makes streetlights, also wants to put an Internet of Things module on there that will also sense traffic patterns. We'll look at maybe even put some sort of electrochemical sensor on there. The ability to get that data onto a network so somebody can see that and look at that and data mine it and collect it really wasn't available until now because the cost of attaching your data to the networks was prohibitive. Now that is not in the way. That is not a barrier anymore. So again, this is a new thing Verizon has launched in the last year. It's called Cat M1 Network for IoT. When 5G comes out, the cost will go down even lower. The amount of data or how much data that comes through these very small IoT sensors is so insignificant that it doesn't even put a hit on their network. So they finally realized that they should offer something like this because they're missing out on a whole segment of market and new revenue streams. So the volume, the 5 ways of the Internet of Things is a very simplistic but very actually powerful slide, I think. 70% of global manufacturers will be utilizing some sort of IoT technology. We're going to create more hundreds of smart objects, hundreds and hundreds of new things that aren't even available right now will be coming out in the next 5 to 10 years. Healthcare organizations. I'll give you an example. Our device has been, again, when I talked about the ability of hooking up third-party peripheral devices, lots of tenant improvement or construction happens in hospitals, and the one biggest thing about hospitals is contamination. So what is normally done is sealing of areas when there's construction, and a negative pressure air situation is what's needed to be making sure that it's completely separated. When containment is broken, it's very hard to determine. Well, with the IoT technology and the ability to put sensors up to the cloud, it's very simple to put a pressure differential device into an area through a little hose that's sealed on the outside with a device that is connected to the internet and will alert somebody when containment has been broken. The only way right now to know if containment has ever been broken is to get there and to monitor it yourself in person. And again, the market itself in 2018 last year was $746 billion. And again, that's a very broad market, but that's where it is at this time. So the real-time solutions design elements. Again, this is a little bit on a techie side, but again, everything in the middle there revolving around the real-time instruments, sensors, communication, data delivery, information, user interface, power, enclosure, and additional sensors or additional services around that. What's the solution? Well, here's what's coming. Instruments, they're available now. We have a solution called SmartSense. There are some other folks out of the Bay Area, AirThinks. There's a company called Aware. They're starting to come online. Again, how are we able to do this? The ability to hook up to a network or communications. There's smaller kits, web interfaces, the ability to digest the data. That's really what's important. reporting information, and then services that revolve around that. So this is an example of our device, actually. It's called the SmartSense device. But what I want to show you is the technology. So around the middle device there is what we call the IoT Gateway. Okay. So the sensors connect all into the IoT Gateway, the hardware platforms. You see a little SUMA canister there. With the ability to communicate bidirectionally in some cases, and in this case, you can actually force a device to go ahead and take a graph sample by itself, autonomously, or you initiate it yourself. Very interesting technology, not just pressure differential, not just SUMA cans. We can even have pumps with filters that can be automatically set when an alert stage has been met in the sensor itself. They will automatically turn on a pump. So you can take draw air through a pump for 30 seconds to 8 hours, and it can all be done autonomously if the device itself feels that an alert level has been met. So this is an interesting slide. I think most people would want to see, okay, this is great, but how do I view the data, or what does the data look like? So this is just one representation of what it's called a digital dashboard would look like. The reason why we have a world map view there is it's just powerful to be able to show this. So let's just say you're a multinational company in the Bay Area, or let's say Seattle, and you're the CIH in charge of every facility in the world. And let's say you have a device, a connected IoT cloud device, at every single one of your facilities. You can even have it on every single floor at every single one of your facilities worldwide. You would have a representation bubble that would pop up on these types of maps. It gives you instantaneous access to every single one of your sensors. Now, if you're not, say you're a local company in Salt Lake City, that's fine. We can have that changed to where you just have it in your local area, and Salt Lake City would pop up there. So you see to the right, you'll see a graphical representation of each sensor. This just shows you, okay, trends over time. You can go backwards in time. You can look, you can run reports of 1 minute, 1 hour, 1 day, 1 month, 1 year. However long you have the sensor in the field, it gives you the graphical information. But more importantly is the statistical numerical values are above there. So each single one of those boxes represents an individual sensor. And that is where you would see the instantaneous remote data coming through. Again, all of this data, graphical or numerical, is coming through and being data cataloged. It is not being lost. Any questions at this point? Really what I want to get across to everybody is don't be afraid of the new technology. It's readily available, I think, now on the internet. But the most important thing to understand is the power of data, the power of long-term data. You set something, a remote monitor out at a particular job, and it is monitoring data points every 30 seconds to a minute. And again, for a day, a week, a month, 6 months, or a year. That is a lot of data. The last thing I'll leave you with is don't always think of this as a problem solver. Everybody has had this scenario to where odor complaints, especially on indoor odor complaints from workers saying they're being harmed. Imagine you put this somewhere near an office or in an area for a week, 2 weeks, a month. All the data comes back in clearly under the PEL, and now you have mountains of data that shows that the air was clean or is unharmful. So look at it both ways. Don't look at it as just an alerting system. Look at it as also a way to clear you. With that, I'm finished.
Okay, great. Thanks, Tim. It looks like we have about 20 or 25 minutes for questions. Just as a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to all panelists. I have a few questions lined up already, and the first one comes from Karen, who says, if I understand what you said, in the very near future, there will be technology to support predictive real-time monitoring. If that is put in place, then I would assume there would be a commensurate decrease in collected IIH samples. How will IH labs respond to this change to continue their existence?
Great question. I want to make sure you guys can hear me.
Yes, we can hear you.
Okay, great.
Yep, I can.
Okay, that is an excellent question. So obviously, I represent SGS Galston Laboratories. So we're a traditional laboratory. About 5 years ago, we saw this coming. And essentially, in the very first meeting, somebody stood up and said, we do not want to go down the same path as Kodak film. Kodak is no longer in business, or very, very limited business, because they did not change with the digital technology. So with the increase and the integration of new technology in the industrial hygiene field, we see a precipitous slide in the amount of traditional lab services that will be needed in the future. We saw it coming. So we said, let's go ahead and lead. We want to lead in the way of remote monitoring. So the business will change, absolutely. Will the need for traditional laboratories go away completely? No. But the demand will decrease. We don't know how far, but it will. And again, as a progressive company, we're always looking forward. And as SGS Galston, it's a global initiative. This isn't just the U.S. Galston division of SGS. This is a global initiative, SGS worldwide. So yes, very observant, and that's a great question.
Great, thanks, Tim. Our next question is, where can I get more information about the pressure differential device online for monitoring containment of hazardous materials?
So when I spoke of that, we purchased just an off-the-shelf pressure differential device and connected it to our whole SmartSense system. I think if you just do a Google search on pressure differential monitor or pressure differential switch, or you can email me directly and I can show you, I can send you information on what we are using that we're connecting up to our SmartSense device.
Thanks, Tim. Our next question looks like it's a two-parter. So Thomas says, the ability to monitor remote sensors via the cloud is a wonderful development, but as a person of the 80s, I have two questions. One, will the IH still be required to bump test remote sensors to ensure the data collected is not garbage? And two, will this technology allow the IH to determine if the alarm is due to a dangerous condition or a sensor failure, such as an expired oxygen sensor in a confined space? And Tim, let me know if you need me to repeat parts of that.
Okay. So in our case, okay, well, let me back up. Most new companies or companies that are coming out with these devices do not calibrate them ahead of time or have the ability to field calibrate. Our SmartSense device is pre-calibrated with gas prior to going out, and we have the ability over the cloud, via the cloud, to do field calibration. So no, there's nothing need to be done by the end user. Second part of that question was again?
The second part of that question was, will this technology allow the IH to determine if the alarm is due to a dangerous condition or a sensor failure?
Great question, and the answer is yes. So there are different types of alarms, at least with our system. One is a dysfunction alarm, and one is an alert. So there's an alert or an alarm. Alert is a state where, well, let me give you the scenario. Each individual user has the ability to, through the digital dashboard, to go into each individual sensor and set an alarm level. So let's just say you're very worried about VOCs. You can go in and set an alert level of, say, 100 ppm, whatever number. So that gives you the ability to set. So as soon as the sensor detects a level above what you've set, that will now trigger a text message alert if you want, or an email alert, or both. And again, that is an alert. There's if there's a malfunction, a sensor goes wrong or something, that's an alarm function or a dysfunction alarm. So there's the ability to distinguish between the two.
Okay, great. Our next question is, how do you address resistance of the workforce to technology that they feel are tracking their every movement and fear that the data will be used to possibly discipline them?
That is a great question, and I'm laughing because I've encountered this. Education is the very first thing, but again, you're going to have those skeptic workers that think that Big Brother's watching over them. So what we do normally is, if you don't set it in their office, you set it out just outside the office. You can actually even mount these things in ceiling tiles and things of that sort where they wouldn't even know. But what I would normally do is just run a report. I would just run a report, download it, show them what comes in the report, and just say, listen, this is it. This is what's in our report. But I guess if you really want to get down to it, it's really an education. And you can even have the representatives, like somebody like myself, help educate the folks. But that is a real issue. I wouldn't say it comes up, every single time, but it comes up for sure.
Thanks, Tim. Our next question is regarding pressure differential devices. This attendee says, I am familiar with manometers used on asbestos abatements. I guess she's Googling manometer and several devices are shown. Maybe that wasn't a question. Maybe I misunderstood. Sorry about that. Did you want to weigh in on any of that, Tim?
Well, I'm not an expert on manometers, but I guess my point to you guys to keep in mind is, you look at this core technology, this hub IoT Gateway technology, like what we have, as the core. You need to be able to understand that other things can connect up into this device that gets it to the cloud that gives you remote visibility. One of them is including pressure differential information. I'll even give you another one. Hydrogen. Really, really low ppb level hydrogen monitors. Other monitors that are out there. Not all diagnostic technologies that are out there are available have been miniaturized into a small sensor that we can embed inside of a little box. But we do have the ability to hook up those peripheral diagnostic devices into the device, basically hang it off it, quote unquote, and then get it to the cloud as well. Eventually, all this technology will be miniaturized and everything can go into one nice streamlined box. But as we sit today, not every technology has miniaturized their stuff because, again, it's expensive and it's a process.
Okay, thanks. Our next question is, who owns the data that is collected, and is software licensing required to view and use the data?
So the answer is the data is always owned by the client. And yes, at least in our case, there is a small software licensing fee, but it's insignificant. It's like a $25 a month type of a thing. And again, there's many folks involved, partners that are involved when it comes to this whole continuum of field analysis, cloud computing, data mining. There isn't any company that has written the software to do all of that. That's all proprietary to one company. We have two partners that allow us to do this whole continuum full circle, and basically it's a pass-through cost.
Okay, great. Our next question is, what are the pathways for data and sample collection validation, and will OSHA and other interested parties see these collection methods as valid?
So the answer to that question is twofold. So what we have done, I'll just speak for us, is taken commercially available components. Each component manufacturer has gone through certification processes. So the individual components are certified. We compilate components into a package that we have created and given connectivity to create something new. Our device does not need to be certified. because it doesn't fall under any of those requirements or guidelines. So to answer your question is, as long as we provide calibration data and things, and manufacturers, MSDS, data sheets on the individual components, from our legal point of view is yes, this is an acceptable method.
Okay, thanks. Our next question is, from an exposure compliance standpoint, how does the data compare against permissible exposure limits, and is it enforceable?
Okay, so let's look at it this way. This technology should not be considered. Let me back up. This is one level above what this question is, what this person is asking. Okay, so let's look at it this way. The devices out there, you're worried about CO2. We set threshold alert levels of CO2. You get an alert of an exceedance of a threshold of CO2. You have this data documented. The data levels, in our estimation, after calibration, are accurate. But what needs to be done at this point is you call that location. You say, hey, what's going on? Or, hey, go grab that specific diagnostic device. Or, hey, grab a pump and go do a more specific diagnostic test. We're not saying that, and you can in some cases leave it where we are at our level. But in some cases, and again, it's a case by case, and we're not going to tell you when or not to do this, but we honestly believe that a dive down one more level is necessary in some cases. So we will never claim that it ends with us. In fact, we encourage you to go dig down deeper.
Okay, thanks. Our next question comes from Susan, who asks, is cloud technology available for noise dosimetry?
The answer is yes. So again, any peripheral third-party device that is out there, as long, in our case, all we need is an analog out, which most devices all have analog out devices. We can, in our case, plug them into our IoT Gateway that comes into our SmartSense device and connects up to the cloud, and you have visibility remotely. Yes, there is noise.
Okay, great. Our next question is, how does collecting data via the cloud mesh with data collected through instruments collected or installed automation systems? I think is the question.
Interesting. So there are other devices, companies that have specific devices that do have communications paths, but they're also proprietary. So I think what they're asking, this person is asking is, if that particular piece of equipment is not hooked up into our system, it will not show up. That would be a whole nother website or a whole nother company's digital dashboard, and that's what they do. But again, what we're trying to do as a quote-unquote IoT hub is, again, plugging peripheral devices in through our gateway that allow you to have one central digital dashboard location to view all of your sensor data.
Okay, great. Our next question is from Rick, who asks, in your opinion, how long will it be before IoT cloud data is combined with voice technologies such as Alexa?
Well, I mean, so that question is asking that it's coming at a whole different direction, right? So I'm looking at we look at things from the whole opposite end of the spectrum. Without hardware, having controlled capabilities through something like an Alexa is really residential, to be honest with you. I would say that.
Sorry, I'm not sure about that.
I would say, sorry, my Alexa just heard me say that. I would say that there are some companies in the Bay Area that are targeting residential. I would say that was probably coming soon, but it's elementary type devices rather than what we're talking about here in hardcore IH. So I guess the answer is, in our field that we're worried about, I would say not anytime soon. But I would also say in residential or domestic type applications, temperature, humidity, pressure, CO2, there are some small devices, very startups that are doing this, and I would imagine they're already talking with Google and Apple on that for sure.
Okay, great. Our next question is, can you apply your IoT systems in potentially explosive atmospheres, and are they intrinsically safe?
The answer right now is no, but it will happen. Intrinsically safe devices are very expensive to build, design, and certify, more importantly. The market is not that big. It is in the oil and gas industry, and they usually trail behind consumer, corporate, industrial grade devices. So the answer is not at this point. I don't know any cloud-based devices that are intrinsically safe at this point, especially for confined space. They will come. Now, what I will say is we have demonstrated SmartSense to every refinery in the Gulf Coast, and really the question or the answer is you just do not put this in any sensitive areas or non-intrinsically safe required areas is what you do.
Okay, our next question is, does Golfin interpret data as a service or only collect it and deliver?
That is a consulting function, and no. But what we do have is an incredible reporting tool available. So in the beginning, all we provided the end user was all the data points. So, one of our first customers did a remote monitoring job for 30 days. We downloaded the data on the CO2 and the H2S sensor, and there was 45,000 lines of data points. And their next question was, well, what now? And we were like, yeah, you're right, what now? So anyway, we've partnered with a company called Terabase now. So the data flows just automatically. You'll have the ability to download through our portal, but it automatically will also, if you choose, will also be dumped into our partner's FTP site. It gets uploaded automatically, and you log into there. And from there, you can run wonderful reports, minimums, maximums, averages. You can run reports for, work time, just, during the day from 8 to 5 p.m. There's graphs. There's all kinds of different things. So we as a company in the last 6 months have gained tremendous advances in the way of data mining. What we've learned is if the client can't read and discern the data effectively, it's not really super effective technology. So we've solved that piece.
Okay, our next question comes from Willie, who asks, will the system work in any remote area where reception is poor with no communication towers?
Well, to get to the cloud, you have to have some sort of communications path. So for instance, we have 5 monitors right now up near the Arctic Circle in northern Canada. We are using satellite. We're using satellite radio technology. So the answer is yes, we can do this. In other cases, not that extreme, we can use 900 megahertz. The optimal way to do it is through cellular technology, or you hop on somebody's local area Wi-Fi network. So it's usually a solvable problem, but there could be some extreme case. But not with satellite communications now. And this was our first time doing this, and we were able to do it. So that was kind of our last unsolvable communications problem we had.
Okay, great. Our next question is, what measures are taken to protect the data from hackers, and how do you protect confidentiality?
Great question. I get that all the time. So again, what does cloud services mean? Cloud services are provided by most every large company in the world: Amazon, Google, EMC. There's a million of them out there. All of these companies have encryption protections there. The data that's flowing through the networks or the Wi-Fi networks, gets encrypted, and again, it's just digital data. There's really nothing there. We can't, like anybody else, 100% ensure that you can't get hacked or insured, but the devices themselves are encrypted when it's accepting the data in and sent out. The cloud services folks themselves have encryption as well. I will never say that there's no way this can happen. It happens to our government systems, and largest corporations in the country are getting hacked. So the data, I think itself, is fairly meaningless, honestly, to only the people that want or are using the system. But it is a concern, and I would never say it can't happen, but it hasn't happened, and I don't know who would want this data, to be honest with you.
Okay, I have a quick clarification from Rick, who asked about the Alexa and voice. He says, in terms of the Alexa question for industry, I was thinking more along the lines of, Alexa, how many hydrogen sulfide alarms have we had in the plant today? He says if the data is in the cloud, he presumes Alexa can access.
I have never been asked that question before. I don't see that, honestly. Again, so then you'd have to partner with Amazon, right? And I don't know how to answer that question, to be honest with you. How we view this is the digital dashboard that we provide, but we're even in talks now with firms that not only do just IH, but they have digital dashboard platforms that you can plug in every single thing that you do within your organization. Environmental testing, water, everything. Everything can now all be compulated, including our data, all in one place. And that's where you have alarms, alerts, things of that sort. So honestly, I can't answer that. I don't know about Alexa or the Google digital assistants. But I guess my answer is there's like type technology that's already here.
Okay, great. Unfortunately, that's all the time we have for today. My thanks to Tim Quinn for his presentation, to SGS Galson for sponsoring today's webinar, and to all of our participants. We have one Synergist webinar planned for 2 weeks from today. On May 1st, Human Tech will present Unlocking the Value of Ergonomics with Big Data. You can register for this event at aiha.webvent.tv. Thanks, everyone, and have a great rest of your day.
All right, this was great. Thank you, everyone. Did you have any last words, Tim?
Yes, thank you. Hopefully that'll work. Okay, sorry
right.
about the audio problem.
No, you're fine. We got you working. Thank you so much, everyone. This concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with this link, and please visit our event calendar to sign up for future webcasts.